Hello, my name is Mr. Asprey and this is EDEXCEL Further Maths. It's Core Pure, it's from 2022 and it is paper 2. Looking forward to doing this paper. I did the first paper back the summer of last year. Didn't get time to do the second paper, so here it is. Okay, a student was asked to answer the following. For the complex numbers, blah and blah, find the argument. This is the attempt. So there is an error made on line 1 apparently. Okay, let's go find that error. Well, the argument of Z1 is going to be in the fourth quadrant, which means it's going to be negative. Because it was going to be pointing down like that. So really what the student should have done is they should have, to find the argument of Z1, done tan to the minus 1 of the opposite being minus 3 over 3. Like this, and this would have given them minus pi over 4. Okay, line 3, there is also an error, and that's just a fundamental error. When you are dividing two complex numbers, the arguments subtract. So the argument of Z1 over Z2 is going to equal the argument of Z1 minus the argument of Z2. Okay, great. So write down the correct value of the arguments. Okay, of the argument of Z1 over Z2. So we need to subtract the two arguments, like we just said. So the argument of Z1 over Z2 is equal to the argument of Z1, which we now know is minus pi over 4, minus the argument of Z2, which we're told, they worked it out for us correctly, pi over 6. Okay, great. So this is the same as minus 3 pi over 12, minus 2 pi over 12, so that's a total of minus 5 pi over 12. Bosh, off and running, let's go. Okay, question 2. Got a lot of text to get through here. Okay, I'll let you read that, and we're going to go down to the question, which is first off to define for each course a variable for the number of students enrolled on that course. Okay, so I'm just going to assign X to construction, Y to design, and Z to hospitality. So I guess to answer that question kind of officially, I would say let X equal the number of students enrolled on construction course in 2019. And then maybe to save myself some time, I'll just do little dots like this, and then this one is design, and again in 2019, and this one would be let Z equal the number in hospitality. Again in 2019. Okay, I'm pretty sure I'll get all the marks for that. Lovely jubbly. Using your variables, write down 3 equations. Okay. So the first one is going to come from the total number of students. So I'll highlight the information where I get this from, and that is that there are that number of students in the college. So the first equation would be X plus Y plus Z is equal to that number, which was 1,110. Okay. The next information that I've been given is this blue one here. It says there are 370 more students on construction and hospitality. So the difference is 370. So if I do construction minus hospitality, I get 370. So if I do x minus z, I should get 370. Okay, and then the final equation comes from the fact that in 2020 we have increased each of these. So I'm going to have to do a multiplier of each of those, and that will give me a new value, which is the old 1110 times by that increase of 0.27. Okay, so let's work that out then. So the first bit, construction was increased by 1.25, so that would be a 1.0125 multiplier by x. And design was increased by 2.5%, so that would be a 1.025 multiplier. And Z was decreased by 2%, so that would be a 0.98 multiplier. And then the overall value of students, or number of students, will be what it was before times by 1.0027. Yeah, that's a 0.27% increase. And that is, for all intents and purposes, particularly as these are people, it has to be a whole number, 1113. Okay, lovely. So those are my equations. So that is part 2 done. And now it says by forming and solving a matrix, basically solve these sets of equations. Okay, so my matrix, let's call it matrix A, has the coefficients of my equations. So 1, 1, 1 is the first row. 1, 0, minus 1, and then, oh, this is not going to be pretty to write these down. Just about squeezed it in there. Okay, that's good. And then we're going to multiply that by the number of students, and then that's going to give me well, the answers to these equations here. So 1110, 370 and 1113. Okay, great. So sorry, I should have put A there now. Okay, so to solve this, then to find x, y, z, I need to multiply by the inverse matrix on both sides, on the left-hand side of both. So I will just show the examiner exactly what I'm doing, and then we're going to use the calculator. So I'm not going to bother finding the inverse matrix, so I don't need to. It just asks me to solve. I'll just put minus 1 up there to represent the inverse, and then I'll multiply that by this here. Okay, great. So now it's all just down to the calculator. So let's get the calculator back up, and let's go into menu, matrix. And we want to define matrix A, and that has 3 rows and 3 columns. And the numbers we're going to use are 1, 1, 1, 1, 0, minus 1, and then 1.0125, 1.025, and 0.98. Great. And then we want to go options, define a second matrix, matrix B. And we want that to have 3 rows and 1 column, and that's going to be our values. So 1110, 370, and 1113. Okay, right, once we've done that, we can press AC, and then we can press options, and I want to print out matrix A, but I want the inverse of it, so I press this button here, x to the minus 1. And then I want to multiply that by matrix B. So I press option and then matrix B, and then I press equals. And bosh, there's our solution. So that's all good. 720, 40, and 350. Beautiful. Job done. Question number 3, and we've got a proof by induction. Okay, so how do we start a proof by induction? We always have to check the base case. So the base case is when n equals 1. And let us see what m to the power of 1 is equal to. So that will be 3 to the 1 over a over 2, 3 to the 1 minus 1, 0 and 1. And this should give us m, basically. So let's see what it does give us. It gives us 3, 0, 1 down here, of course, and then 3 minus 1 is 2. There's a times by a half, so that's just a, which equals m. Perfect. So that's true. So we can say this is true for n equals 1. Perfect. Okay, and then what we do is we assume true. So we're going to say assume true for n equals k, like such. And if that is the case, then I can just write down that m to the k is going to equal this matrix, but with the n replaced with the k. So that would be 3 to the k, it would be a over 2, 3 to the k minus 1, and it would have a 0 and it will have a 1 there. Okay, right, next up is the induction stage. So the induction step asks us to let n equal k plus 1. Okay, so what do we get? M k plus 1. What is m to the k plus 1? Well, it is m to the k multiplied by m. Now, what do we want it to equal? Well, what we really want is we want it to be the same as the original, which is this, but we want the k's replaced with k plus 1s. So this is what we want. This is like our target. Okay, which I always do on the side of the page over there, just to make sure that it all comes together nicely. Okay, so this is what we want this to equal. We want it to look something like this. This is like our target. Yeah. Okay, and how we're going to get there is we're going to, using the assumption, which we know m to the k, and if we multiply it by another m, then we should get m plus 1. Or k, sorry, we should get m to the k plus 1. Okay, so m to the k is 3 to the k, a over 2, 3 to the k minus 1, 0, 1. We've assumed that, that's fine. And we're multiplying that by m. Let's just remind ourselves what a single m is. It's 3a, 0, 1. So 3a, 0, 1. Okay, so we're going to have to do this multiplication and we're going to have to hope that it comes out to what we want it to. And if it does, then we have proved it. So let's multiply across. So we're going to do 3k times 3 first. So I'll write that as 3 times 3k. And then we're going to do this a over 2, 3k minus 1 times 0, which is just going to give us nothing. So that's the first element done. The second element, the top right one, is the top row times by the right column. So that would be 3k times by a. So that will be a times by 3 to the k. 3 to the k times a. And then the next part will be this a over 2 3k minus 1 times by 1, which we'll add on, so we get this. Okay, bottom left is 0 times by 3, which is 0, and then 1 times by 0 is also 0. Bottom right is 0 times a, and 1 times 1, so that's just 1. Okay, great. Right, now to simplify. Well, the top left is 3 times 3 to the k, so that's the same as 3 to the 1 times 3 to the k. And what do we do when we multiply bases that are the same? We add the powers. So this becomes 3 to the k plus 1. Okay, what have we got going on over here? Well, let's expand out. We've got a times 3 to the k, and we've got another a over 2 times 3 to the k minus a over 2. And down the bottom we get 0 and 1. Okay, we need to simplify this. Well, and let's have a look what we want, because that's always helpful. Okay, so what we want has a factor of a over 2 on the outside. So let's take out a factor of a over 2. So if I take out a over 2, then the first term, well, is times the a, so I'd have to times it by 2 in order to cancel out that half. So it would be 2 times 3 to the k. Yeah, because the 2 and the half cancel, and then you've just got a times 3 to the k, which is what we want. The next term we can take out that a over 2, and we're left with 3 to the k. And here, well, we can take out a over 2, leaves us with 1, so minus 1. Okay, and now how many 3 to the k's do we have? We've got two here, and we've got 1 here, so we've got a total of 3. And like we said before, 3 times 3 to the k is 3 to the k plus 1. So it looks like we are getting very close now, so we can say a over 2, and this is 3 to the k plus 1 minus 1. And this is 0, and this is 1. And this is exactly what we want, as you can see here, so we've proved it. So we can then say this is true for n is equal to k plus 1 when assumed true for n equals k. And as well, it is true for n equals 1. And then we can say, therefore, it is true for all n being natural numbers. I think it says natural numbers, or is it integers? Depends what the question asks. It says natural numbers there. Perfect. Okay, so natural numbers. Yeah, so we're good. That is the end of the proof. Okay, I'm going to grab some more space for the next question. Okay, next part of the question says that we have a triangle and it's been transformed by the matrix that we've just proved. And it says, given that the triangle had area of 5 but now has area of 1, 2, 1, 5. Okay, so that means that the area scale factor is 1,215 divided by 5, which is 243. Okay, that's helpful. We've also got information that one point has been transformed, so we know what that is. And then it just says find the value of n and find the value of a. Okay, so what do we know about the area scale factor? We know the area scale factor is always equal to the determinant of the transformational matrix. And the determinant we get of a 2 by 2 we get by doing a times d in the first instance, which is 3n, and then minus b times c, which is 0 in this case, so we don't need to concern about that. Okay, so 3 to the n is equal to 2, 4, 3, so that means that n equals 5, because the fifth power of 3 is 2, 4, 3. Great, that's n done, and now EDEXCEL are really quite nice when they give information. We've used both of these bullet points, so what are we going to be doing next? We're going to use this bullet point. So I know that the matrix, when used on the point A, is going to give me this new point. So if I do the matrix, which is 3n, which we now know is 3 to the 5, which we now know is 2, 4, 3. A over 2 times by 3 to the n minus 1, which is now going to be 2, 4, 2, and 0 and 1. This is going to multiply with 2 minus 2, and it's going to give me my new coordinate, which is 1, 2, 3 minus 2. Okay, great. Let's just tidy this up a bit, because this is a over 2, it's going to give me 1, 2, 1a. Right, so multiplying the top row, so 2, 4, 3 times 2 is, of course, 4, 8, 6. And then minus 2 times 121a is minus 242a. And this is going to equal 123. There we go. Right, we can solve for a now. So let's just bosh this in the calculator. Subtract 1, 2, 3. It's going to give me 3, 6, 3, and that's going to equal 2, 4, 2a. Divide through, that's going to give me 1.5. Bosh. There are my solutions. Happy days. Question 4. Given that z1 is equal to this and z2 is equal to that, show that when we add them, we get that. Okay, well, it's quite difficult to add them in that form, so we need to convert them first. So we're going to say z1 is equal to the modulus, which is 6, or the magnitude, sorry, and cos of the argument, which is pi over 3, plus I sine of the argument, which is also pi over 3. That's Z1, and Z2, in fact, what I'll do is I'll just add them straight away, just to save a bit of time. So Z1 plus Z2 equals, there we go, that's better. 6 root 3 is the magnitude of the second complex number, and again we have cos of the magnitude, which is 5 pi over 6, plus I sine of the magnitude, which again is 5 pi over 6. Okay, so making sure our calculator is in radian mode, we will do cos of pi over 3, which is of course a half. So this becomes 6 and then just a half. And sine of pi over 3, as we know, is root 3 over 2. So plus I root 3 over 2. And then we have 6 root 3. And we're doing cos of 5 pi over 3. Sorry, over 6. Which is minus 3 root 2, minus root 3 over 2, sorry. And then we do sine of 5 pi over 6. And what do we get? We get a half. Plus I times by a half. Okay, let's multiply these out. 6 times a half is 3. 6 times root 3 over 2 is 3 root 3. So 3 root 3 I there. And here, root 3 times root 3 is 3. There's a minus there. And 6 over 2 is also 3, so it's minus 9. And we have a half times by root 3 times 6, which is 3 root 3. So plus 3 root 3 I. Okay, so what do we get in total? Add up the reals, we get minus 6. Add up the complex imaginaries, we get 6 root 3 I. Okay, still not quite done there. We need to find the, we need it in magnitude form, magnitude argument form, exponential form even. But in order for us to get exponential form, we're going to need to find the magnitude. So the magnitude of this is going to equal the square root of 6 squared plus 6 root 3 squared, which gives me 12. Okay, it is a show that question, so I'm just going to like really clearly show what I'm doing here, just to make sure I get all the marks, and that equals 12. Okay, so to find the argument, well, if I were to draw this quickly on an argon diagram, it's minus 6, so that goes to the left, and then up 6 root 3, which goes up like that. So the complex number looks like this. So what we need is we need this angle in here. So we do pi minus tan to the minus 1 of the opposite, which is 6 root 3 over the adjacent, which is 6. Okay, so on our calculator we do pi minus, because pi is 180 degrees, and I don't want just this angle in here, I want the other angle, so 180 minus, and then we do tan to the minus 1 of, well, 6 root 3 over 6 is just root 3, isn't it? So let's just do root 3. Okay, great. 2 over 3 pi. So 2 pi over 3. Okay, and that's to be expected because they've actually given us the answer. So we can now say that Z1 plus Z2 is equal to 12e to the 2 pi over 3i in exponential form, where we use the magnitude and the argument. Great. Next question. We okay, so to do this question, I'm definitely going to want to draw an argon diagram to get a sense of what's going on. So when I draw my argon diagram, it's going to look something like this. And what does this mean? Well, this is the half line starting at the point 5, 0. So this point here, 5. Because remember, we have to make sure that we want to do z minus whatever the starting point is. So in this case, z1 is just equal to 5. So on an argon diagram, that goes right there. And the half line has an angle of 2 pi over 3, which is it's 120 degrees. So the line would go roughly like this. And this angle in here would be 60 degrees or pi over 3. Now, what does this question actually ask? It says determine the least value of the modulus of z as z varies. Well, the modulus of z, or the magnitude of z, is the distance from the origin of the given complex number, which happens to be on this red line. So what we're going to need to do is, if we want it to be the smallest distance, then it needs to be perpendicular to the red line. That's the quickest way of getting from the origin to the red line, is by doing a perpendicular line there. Okay, so I want to work out what the value of this green line is. That would be the smallest value or distance that Z can take. So this is just simply a SOHCAHTOA question now. So sine of pi over 3 is equal to the opposite, which happens to be the one we're trying to find, and the hypotenuse, which is 5, this distance along here. So the opposite is the magnitude of Z, and the adjacent is 5. So the least magnitude of Z is going to be 5 sine pi over 3, and that is equal to pi over 3 of sine of pi over 3 is root 3 over 2. So 5 root 3 over 2. Bosh! Come on. Okay, next question. It says, given that y is equal to arcsine x, show that the derivative is equal to 1 over the square root of 1 minus x squared. Interestingly, you can kind of be asked this question in regular maths, but they would write it in a slightly different way, because you don't have to do anything to do with arcsine other than draw graphs of it. But let's do this. What would you do? So you'd sine both sides is the starting point. So if I take sine of both sides, then I have this arcsine of x. And of course, sine of arcsine of x is just x, because sine and arcsine are inverses of each other. Okay, and then we differentiate implicitly. So to differentiate sine y with respect to x is going to give me cos y, but we have to multiply by dy by dx because we're differentiating with respect to x rather than y. And when I differentiate x with respect to x, I just get 1. Okay, so this tells me that dy by dx is equal to 1 over cos y. Okay, now we need an expression for cos y in terms of x. So we're going to take this expression, sine y is equal to x, and we're going to square it. We then know that sine squared is 1 minus cos squared. I'm not sure why I did a bracket there. Don't need that. Okay, so rearranging, this gives me that cos squared y is equal to 1 minus x squared, which tells me that cos y is equal to the square root of 1 minus x squared. And now we can combine these two things, and we get that dy by dx is equal to 1 over, rather than cos y, I'm going to replace that with the square root of 1 minus x squared. And we are done. Okay, now we need to prove that this function has no stationary points. Okay, no problem. So, as soon as you see the word stationary points, you know you've got to differentiate it. So let's just start by saying y is equal to arc sine of e to the x. And we're going to use the chain rule to differentiate this. So I'll say that y is equal to arc sine of u, where u is equal to e to the x. And then we differentiate y with respect to u. In fact, let's just write that just so it's nice and clear to show everyone what we're doing. We do dy by du. So we already know what this is because we've already differentiated arc sine. You get 1 over the square root of 1 minus the variable squared. And then let's differentiate this with respect to x, so du by dx, and we just get e to the x, of course. Okay, so now we can show that dy by dx, so the derivative of this function arcsine e of x, is dy by du times by du by dx. So this is 1 over the square root of 1 minus u squared multiplied by e to the x. So this is equal to, put e to the x on top, over the square root of 1 minus, and u is e to the x, so u squared is e to the x times e to the x, which is e to the 2x. So e to the 2x. Okay, and this doesn't equal 0. It can't possibly equal 0 because for it to equal 0, the numerator must equal 0, and we know that e to the x never equals 0. So therefore, always put a conclusory statement in. Therefore, f of x, which was the function, has no stationary points. Beautiful. Question 6, let's go. Roots of polynomials. Okay, so before we get started, it's important to know that the sum of the roots is minus b over a, which in this case is going to be minus p over 4. The sum of the roots paired is equal to c over a, which in this case is minus 14 over 4. And the sum of all of them multiplied together, which is just going to be alpha times beta times gamma, is keeping with the pattern, is equal to minus d over a, which in this case is minus q over 4. Okay, so you should know from your notes that alpha squared plus beta squared plus gamma squared is equal to the sum of the roots squared minus 2 lots of the sum of the pairs. I mean, if you don't know that in your exam, I mean, you could always just square this out and see what comes out, and then collect them up and then see what the pattern is. Okay, so but because we know this, I'm just going to go straight into using this. So that's minus p over 4. We know this side is 16, we're told that. Minus p over 4 squared, and then minus 2 lots of minus 14 over 4. Okay, so this gives me 16 is equal to p squared over 16, and then this would be plus 14 over 2, which is 7. Okay, great. So now this means that p squared is equal to 16 minus 7 is 9, times by 16 is 144, so p equals 12. Okay, great, that's part A done. Part B. Okay, the reciprocals. So we should know that, again, from our notes, the sum of the reciprocals is equal to the sum of the pairs over the triples. Again, if you're not sure about that, what could we do in our exam if we didn't know? Well, we could make all of these have a common denominator of alpha, beta, gamma, and then when they do have a common denominator, you'll get beta gamma on top. You get beta gamma on top plus alpha gamma plus alpha beta, which is exactly what we've got here. Okay, so this is going to be minus 14 over 4, all over minus q over 4. So this is the same as minus 14 over minus q. And we know, we've been told already, sorry, this is 14 over 3. So just from inspection here, we can see that q is equal to 3. Okay, great. Right, part C. Okay, there are two ways of doing a question like this. So this is a transposition of roots. So we could do it that way, or we could multiply this out and then just apply it to our formulas that we've got here. I'm probably just going to multiply out. Perhaps I'll do the other way as well, just to show that it works out. But for now, let's just multiply it out. So I get alpha beta minus alpha minus beta plus 1. And that needs to be times by gamma minus 1. Which is going to give me alpha beta gamma minus alpha gamma minus beta gamma plus gamma, and it's going to give me minus alpha beta plus alpha plus beta minus 1. Okay, great. So let's collect it all up and see what we've got. Well, we've got an alpha beta gamma. Looks to me like we've got a minus sum of the pairs. So you've got here are all the pairs, and they've all got a minus sign there. And we've also got the roots just added together, so that's just the sum of the roots. And then we've got minus 1. Okay, so what is alpha beta gamma? That's minus d over a, which is minus q over a, minus q over 4. So that's minus 3 over 4. The sum of the pairs we said was minus 14 over 4. And the sum of the roots was minus p over 4. P was 12, so minus 12 over 4 is minus 3. And minus 1. Okay. So what have we got here? We've got 14 over 4 minus 3 over 4 is 11 over 4. And we've got minus 3 minus 1 is minus 4. So that's 11 over 4 minus 16 over 4, which is minus 5 over 4. Bosh. Job done. Okay, question 7, polar coordinates. We've got a line, and it says that the tangent, a curve, it says the tangent is perpendicular to the initial line. Okay, so what we know about that is that it's the dx by d theta is equal to 0 at that particular point, so that's the point A. So what we need is the line equation in terms of x. So our x coordinate is x equal to r cos theta. So let's combine this and our line equation. So I'll write x is equal to r, we're going to replace with the line equation, which is 1 plus tan theta, and then we're going to multiply that by cos theta. Okay, so multiplying out is going to give me cos theta plus cos times the tan is sine. Whoops, let me just write theta in there. So plus sine theta. And then we're going to differentiate that with respect to theta. Cos differentiates to minus sine, and sine differentiates to cos. And we're going to set that equal to 0 because that's going to tell us the exact point where the gradient is perpendicular to the initial line, which is the point A. Okay, so solving this equation, I'm going to move the sign to the other side. and then I'm going to divide through by cos to give me 1 is equal to tan theta, and then inverse or arctan of 1 is of course pi over 4, and that is in the range, perfect, and no other values would be in the range, so we know that is the 1. Okay, now let's find the r value for a theta value of pi over 4. And how are we going to do that? We're just going to sub that into the line. So the line is 1 plus tan theta. So that is 1 plus tan of pi over 4, which is 1. So that's 1 plus 1 is 2. And I think we've done. So what I could do is just underline this and underline this, and that has proved the point A has that coordinate. Okay, perfect. Right, next we need to use calculus to find the shaded region. Okay. Well, first off, from the origin to A, we know that this angle in here is pi over 4. We've just proved that. And we also know that when you do a half line like that, and then also a half line going maybe at 0, then the area of the sector, which will be this purple area here, so it's the area contained by the two half lines and the curve, that is found by integrating and using our sector formula. So that red area is going to be the integral between pi over 4 and 0 of a half r squared d theta. Okay, great. So we could do that. So what I'm going to do is write that as a half the integral of r, which we know is 1 plus tan, and then squared. We're going to multiply that out, and that's going to give us 1 plus 2 tan theta plus tan squared theta. And tan squared is quite tricky to integrate, so we need to do a substitution for that. And we know that tan squared theta plus 1 is equal to sec squared theta. So rearranging that, tan squared theta is equal to sec squared theta minus 1. And that's much easier to integrate, so we're going to sub that in. Keeping this the same, so we have 1 plus 2 tan theta, and now we have plus sec squared theta minus 1. Okay, that's helpful. We know this 1 and this minus 1 will cancel, and then we just need to integrate these terms. Okay, so what does tan integrate to? Tan integrates to ln sec, and that is in your formula booklet. So that's 2 ln sec theta. Perfect. And what does sec squared integrate to? Well, that integrates to tan, because we know that tan differentiates to sec squared. So that is just going to be tan theta, just like that. And that is between pi over 4 and 0. Okay, great. Right, so now to substitute in our limits. Okay, so we're going to use the calculator just to be double sure. It's in radian mode, and we're inputting into sec, which we can't do on our calculator. Well, we can do 1 divided by cos of pi over 4. Okay, that's going to give me root 2. So that's my first term. So it's 2 lots of ln root 2. And then when I sub pi over 4 into tan, we know that already, it gives us 1. And then when I sub 0 into cos first, we get 1, and then sec is 1 divided by that, so that is 1. So that's going to be 2 ln 1. And then when I sub 0 into tan, that's just going to give me 0. Okay, and what is ln 1? Ln 1 is 0. So this final bracket is just 0. Okay, let's see if we can simplify this a little bit more. Well, the half, when I multiply, is going to give me ln 2 plus 1/2, like that. Sorry, ln of root 2 plus 1/2. And then ln of root 2 is the same as ln of 2 to the half. I can bring the half from that ln down to the front using log rules. So I can say this is a half of ln 2 plus 1. Okay, great. Let's go back up to our diagram. So we're not quite finished yet, because that doesn't actually give us the that doesn't give us the shaded region. It gives us the pink region. So to find the shaded region, I'm going to need to work out the area of the triangle. So let me do that in a different color. So the area of the triangle is going to be from here and then to here and then across here. Now that's going to have the x coordinate of A, because it's how far along from the origin A is, and it's going to have the y coordinate of A. So the x coordinate of A is what's the x coordinate of A? It's r cos theta, and we know what r and theta is. So r is 2 and cos of theta is pi over 4. So this is going to give me 2 root 2 over 2, so that's just going to give me root 2. Okay, what about the y coordinate? Well, that's r sine theta, and that's going to give me 2 sine of pi over 4, which is also the same. It's 2 root 2 over 2, so it is just root 2. Okay, so the area of the triangle is equal to a half base times by height. So that's just going to give me 1. Okay, so now we are finally ready to work out what r is. So r is equal to the whole triangle 1 minus what we integrated, which was a half ln 2 plus 1, I think. Yes, plus 1. Lovely. Plus 1. This is going to give me 1 minus a half ln 2 minus a half. 1 minus a half is a half, so it's a half minus a half ln 2, which is a half 1 minus ln 2. And I believe that is what they're looking for. Yes, it is. Job done. Okay, next question. We've got 2 birds are flying towards their nest, which is in a tree relative to a fixed origin. The flight path of each bird is modelled as by a straight line. Yada, yada, yada. Yeah, you've got one line and you've got another line. And the question asks, well, the angle between them is 120, so determine the value of A. Okay, so we're going to use our formula. So we're going to dot the 2 directional vectors, which is this, this, and this. We're going to divide it by their magnitudes, which will be 2 squared plus A squared. And this one will be 1 squared plus 1 squared, so just root 2. And that's going to equal cosine of the angle between them, which is 120. Okay, so let's look at the dot product first. That will be 2 times 0 is 0, A times 1 is A, and 0 times minus 1 is 0, so it's just A on top. On the bottom, this is 4 plus A squared, and then root 2. And cos of 120 is, pretty sure, I'm going to go out on a limb here and say it is minus a half. Yeah, minus a half. Okay, so if I square top and bottom, that's going to give me a squared. I'm going to get 2 times by 4 plus a squared. I could do that because these two things on the bottom are multiplied together. When you square, you literally just square each part and keep them times together. And this will give me 1 over 4. Okay, conscious I'm running out of space here, so let's bring this down to the bottom. So that was a squared over 2, 4 plus a squared is equal to 1/4. Okay, cross multiplying gives me 4a squared is equal to 2, 4 plus a squared. Multiplying out those brackets gives me 8 plus 2a squared, and subtracting like this, and then dividing gives me this, and then I get plus or minus 2. Okay, right, listen up, the most important word in your A-level maths is this one here, value. So many marks could be lost or gained because of that word. And that is a singular word, it is not pluralized, which means there's only one answer. So I've got to figure out which answer it is. If it's the plus or is it the minus. And I'm going to look at this part right here. This is going to tell me if it's plus or minus. Because this left-hand expression must be negative, because the right-hand side is negative. So where is that negative going to come from? Because it's not going to come from the denominator, because those are going to be square rooted, and that is going to give you a positive value. What it is going to come from is the top, which is a, which means a is negative. Okay, because the bottom is the magnitude, it's literally the magnitude of a and b, so that's always going to be positive. So the top needs to be the negative part. So a is negative, which means we can say that a is equal to minus 2 only. Sweet. Verify that according to the model there is a common point on the flight paths of the two birds and find the coordinates of this common point. Okay, so we've got to solve these simultaneously. So I'm just going to write them below and then we can carry on. Okay, so what I've done is I've taken these equations of these lines and I've written them out in terms of x, y and z right down here. So this is the first line, this is the second line. Now we need to solve them simultaneously and we need to check to see if it works for all three equations. Okay, so if I look at x first, then I have 1 minus 2 lambda equals 4. If they meet, then the x values will be the same, which means that 2 lambda equals 5, so lambda equals 5 over 2. Okay, now if I look at the z's next, then I get 2 must equal 3 minus mu, which tells me that mu must equal 1. Okay, great, so I've used two equations now. I've got to verify that this works for the third equation, which happens to be the middle one. Okay, so let's do that over here. So the middle equation gives me 5 minus 2 lots of 5 over 2. And is this going to equal the other side, which is minus 1 plus mu is 1? Well, this side is 0 and this side is 0, so yes, it does work. And that means that the lines intersect. And I believe it asks for the exact the exact intersection point. Well, this is good. We can find this fairly straightforward because the x coordinate is given for us. It's 4. X is always 4 on that line, and the z coordinate is always 2 on that line. And we've also shown that they intersect at 0 and 0. So there we have it. That is where the two lines meet. So as a coordinate, that would be 4, 0, 2. Perfect. Okay, the position of the nest is modelled as being a common point. The tree containing the nest is in a park. How lovely. The ground level of the park is modelled by the plane given as this. Determine the shortest distance from the nest to the ground level of the park. Okay, so let's bear in mind that the normal of this equation, the perpendicular direction, is given as the coefficients of the x, y, and z. And also let's bear in mind that there is a formula that tells us the quickest way of getting from a point to a plane. Okay, and that formula is also in your formula booklet, and it looks like this. So it's A alpha plus B beta plus C gamma minus D all over the modulus of A squared plus B squared plus C squared. Perfect. Okay, so what are these things? Well, the ABC is the normal vector, which we said was 2, minus 3, and 1. And D is the constant which the plane is equal to, so 2. And the alpha, beta, gamma is the point which we are working out how far away it is. So just remind myself that so it was 2 minus 3, 1. So I'm going to multiply those together. So I get 2 times 4. I get plus 0 times minus 3. And plus 2 times 1. And then minus the constant, which was 2. And that's all over the square root of 2 squared plus minus 3 squared plus 1 squared. Okay, lovely. So I'll pop that in my calculator and see what we get. Okay, so we get 4 root 14 over 7. This is a vectors question where we're modelling, so it's not a good idea to give it an exact form. We want it in terms of whatever the unit is, which is 2.38. Let's just see. They don't specify. Okay, they don't specify the units. Fair enough. Strange. Okay, by considering the model, comment on whether or not your answer to part C is reliable, giving a reason for your answer. It's unlikely to be reliable. So it's unlikely to be reliable as the birds are unlikely to fly in straight lines. Or you could say that the floor is unlikely to be completely flat. Things like that. Okay, final question, and we have y is equal to cosh n to the x, and it says show that the second derivative is equal to this. Holy moly! Okay, right. Let's get differentiating then. So the first derivative, this is using the chain rule, which I hope everyone is comfortable with. The n will come down to the front, become the new coefficient. We would write cosh, and we would drop the power down by 1, and then we'd always have to multiply by the function itself, its derivative. So I've got to multiply by the derivative of cosh, which is sin x. Okay, so that's the first derivative. That's just using the chain rule. The second derivative, I will need to use the chain rule and the product rule. So let's start by differentiating. So the first bit, which is the n cosh n to the minus 1 of x. So the n minus 1 power comes down. We write out the function cosh again, but we drop the power down by 1. And then we multiply that by its derivative. So that is me differentiating that, and then I need to multiply that by the second part. So this is the first part, and this is the second part. I'm using the product rule. So I'm differentiating the first part, and then I'm multiplying it by the second part. And then I've got to do the opposite. I've got to keep the first part the same and multiply by the derivative of the second part. So this gives me n cosh n minus 1 of x multiplied by the derivative of sine of x, which is cosh x. Okay, that's all good. And then what we're going to do is just tidy it up somewhat. I'm going to write n minus 1, have it that way round, because I can see it is like that in the question. This cosh n minus 2, I'll keep that like it is. That's a sine squared, and of course we know that cosh squared x minus sine squared x equals 1. So that sine squared x can be written as cosh squared x minus 1. So I'm going to do that. I'm going to have it in there. I'm going to do cosh squared x minus 1. And over here, well, I've got two coshes times together, so what that means is we're going to add their powers together. So that's cosh n minus 1, and that's just cosh to the 1. Add those powers together, it's going to give us cosh to the n. Okay, I'm going to multiply out these brackets. And when I times cosh to the n minus 2 by cosh squared, again the powers are going to add, so that will give us just cosh to the n. And then I also need to multiply that by minus 1 as well, so I get minus n minus 1 cosh to the n minus 2 of x. Okay, so what I've done there, just to clarify, is I have multiplied out, I've times this part by cosh squared, and then I've times it by minus 1. Okay, and that's plus n cosh n x. Okay, now let's do some pairing up. So this, we have that right here. That's that. So I've now got to then, well, formulate the rest of it using what's left over. So how many cosh squareds have we got? Aha, right, so we multiply that out, we've got n squared times cosh to the n, and we've also got minus n cosh to the n. We've got this thing which is good to keep, and then we've got an n cosh to the n there. So that is going to cancel with that, and that is going to leave us exactly with what we're looking for, and that is n squared cosh to the n of x minus n minus 1 cosh to the n minus 2 of x. Perfect. Determine an expression for the fourth derivative. Are you having a laugh? That was, all of that was to get the second derivative, and I'm not doing that again, so we're going to have to come up with some better way of doing this, because it's only for 2 marks. Okay, so well, I know. Okay, so we know what cosh to the n differentiates to. If I differentiate twice, I know what that gives me, because we've literally just done that. So when I see a cosh to the n of x, and if I want to find the fourth derivative, I'm looking at the second derivative, and every time I see a cosh to the n of x, I know what that's going to differentiate to. Okay, so how am I going to find the fourth derivative then? Well, I know what cosh to the n of x differentiates to when I differentiate it twice, which I need to do because I need to go from the second to the fourth. So I've got to differentiate this 2 more times, and I know what this differentiates to. The n squared is just a constant, which will stay. So it becomes n squared lots of, well, what do I get when I differentiate cosh to the n? I get n squared cosh to the n of x minus n minus 1 cosh to the n minus 2 of x. Okay. Now what I need to do is I need to differentiate this part, which is a bit trickier. And what I'm going to do is I'm just going to do a little substitution. I'm going to say let me do it in a different colour. Yeah, let's let n minus 2 equal u. And then this will become that chunk there. Well, that would also mean that n would equal u plus 2, and it means that n minus 1 will equal u plus 1. So this now becomes u plus 2, u plus 1, and then cosh to the u of x. Okay, now we know what this differentiates to, because it just differentiates to this line here, but with u's instead of n's. Okay, so let's differentiate that twice, and let's see what we get. This will stay the same, the constant in the front will stay the same, so u plus 2, u plus 1 will stay the same as well, but cosh to the u, what does that differentiate to? It differentiates to u squared cosh of u x minus u minus 1 cosh of u minus 2 of x. Okay, so now let's just replace that with the n's. Sorry, it shouldn't be an equal sign there because it's all sort of one thing. And let's bring it all together. Okay, so the fourth derivative is equal to n squared cosh n of x minus n minus 1 cosh n minus 2 of x minus n minus 1 times by u squared, which is n minus 2 squared, cosh of u, which is n minus 2, minus n minus 2 n minus 3 cosh of u minus 2, which is n minus 4 of x. Wowza. Okay. Okay, next question. Determine the first 3 non-zero terms of the Maclaurin series. Okay, so what we're going to need to do is Maclaurin always acts around x equals 0. So the y value would be cosh of 0, and that's always going to be 1, no matter what power you raise it to. The first derivative, if I remember correctly, had a shine involved. Just double check that. Yeah, you see here the first derivative has a shine, and shine of 0 is 0, so that's going to give me 0. Okay, the second derivative, well, that's what we calculated. and this is going to equal, well, cosh, the cosh part is going to give me 1, so that's going to be n squared. Again, the cosh part is going to give me 1, so it's going to be n squared minus n minus 1. So it'd be n squared minus n minus 1, which is going to be n squared minus n squared plus n. So that's just going to be n. Okay, now this is going to work in a pattern in that when I differentiate the second derivative, I will also get a sign. So that is going to give me 0 as well. And that's why we've been asked to work out the fourth derivative in order to get our first 3 non-zero terms. Okay, so let's have a look at what this is going to give us then. Holy moly. Right, all the coshes are going to be 1. So, God, we're going to have n squared, n squared minus n minus 1, close brackets, minus n minus 1, oh God, it's crazy, n minus 2 squared minus n minus 2 n minus 3. Oh my God. Okay, I've done all the legwork and this simplifies down to 3n squared minus 2n. Obviously check it if you want, but I don't want to waste too much time in the video, and that's what it simplifies to. So that gives you this, and then that means that you've got our function, which is going to be Maclaurin series is 1 plus, and then it's going to be nx over 2 factorial, which is 2, and then we're going to have 3n squared minus 2n. That's going to be times by x to the 4, and that'll be over 4 factorial, which is 24. Wow, what a question, what a paper. I hope you enjoyed that. If you do, like, subscribe, and I will see you in the next one.